Hello YouTube, welcome to my Lua Python leetcode problem solving video. And we're on the second episode. Honestly, I thought this was an easy problem because it says easy, but it seems as if it might be a little hard to explain. But the code to it is rather small, but I will just explain the problem to you guys. Hopefully you guys know basic understanding of Lua or Python because we'll be using those languages to solve this problem. So it says you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? Okay guys, so what this problem is asking, if there is a staircase of one step, let's say this is a staircase of one step. If you start from the bottom, how many times how many steps does it take for you to get over here? Basically, you're gonna have to travel one time. The problem is saying you can either climb one or two steps. So you can climb one time or two times. But if you go +2 over here, then that means you're out of bounds. And that means you're on the second step, but we don't want the second step. If the n equals 1, then that is one staircase. Okay, so if n equals 2, then that means there's two steps over here. And then the answer for that would be 2 times. So you take two number 1 steps, right? You take one step plus one step, and that's going to give you a 2-step. Or you can go the other way, which is you just take 2 steps here. So that is going to be our other way, and that's going to equal to 2. So then in our output, we would probably need to store this somewhere. So let's say we have this, then our length of this list of how much numbers are in here is the answer to our problem. So if n equals 2, our answer to our problem would be 2 because there are 2 ways that we can get to step 2, which is this and that. And if n equals 1, then there would just be one way, which would be 1 just like that, equal 1. Okay, so hopefully that makes sense to you guys. That is what this explanation is. Explaining 1 plus 1 is going to be 2, and then just 2 steps is going to be 2. Okay, and 3 is 3 steps. You're going to take one step, one step, one step, one step plus 2 steps, 2 steps plus 1 step. So hopefully you guys understand that problem. We're going to do it with 3. It's going to be 1, 2, 3. And that is our first way to get here, which is going to be equal to n. So then we do 1, 2. So that means 2 plus 1 equals 3, which equals to n. That is if our n equals 3. And then another way, we'll use this color, which is 1 plus Bing. So it's kind of hard to draw this on, keep doing it for 4, 5, 6, 7, because you're gonna have to keep displaying this list. But basically, so that, wait, whoops, my bad. It's supposed to be like this, 1 and then 2. So 1 and 2 is going to equal to n. So we don't usually draw this in computer science. What we usually do is we make a decision tree and we start from here. Just say this point is literally this thing right here. And there are 2 ways that we can go, which is we can take 1 step or 2 steps. And over here we have 1 in this decision tree, which we can go 1 step or 2 steps. So this 1 step, if we're over here, that means we're on this step. And if we're over here, then that means we're on this step. Okay, I think that makes sense. And then we have another way, is we can go another 1 time. and we can reach, if we add 1 plus 1, that's going to give us 2. And then on this side, it's going to be 1 right here plus 2 is going to give us 3. So if you follow this tree, it's just going to, this is going to be like the outcome of where we're at. So if we go this way, 2 and 1, well, we gotta go, we only can take valid steps of 1 and 2. So 2 plus 1 is 3, 2 plus 2 is 4. So let's say we wanted to get to here, right? This n number, if n equals 1. This right here, it actually means how many, if you're over here and you're at like n equals 1, it means you have to see how many times 1 is in this tree of like length 1, because we wouldn't want to generate a tree of like 99 and only need this value of 1 here. That wouldn't make any sense. Like draw that whole tree. So that means there are, so let's just put it in red. If we want 1, that means there are 1 in this tree. Okay? So if we want 2, that means there are, we have to go to the second level. If n equals 2, then we want to go to the second level of this tree and look at all the values in this list that contains 2, or that has 2. So there are 2 ways to get to 2, which is this 2 right here. Right here you go 2, and then there's this one way and another way. There's 1 and 1. 1 and 1. So this is what our 2 is going to be looking like. So let's say we get to 3, okay, n equals 3. So that means we got to do 3, 4, just adding 1 and 2 to the left and right. 3 and 4, 4, 5, 4, 5, 4, 5, 6. So if we need 3, we're going to look at this level of tree, this tree level, and we're going to count how much 3s we have. Well, 1, 2, 3. Yeah, I guess 3 equals 3. 3 equals 3. Okay. So how we actually get like the value of 3 over here, let's see, this number, is there are only 2 values that can lead to these 3. And those values are this 2 right here and this 1 right here. You see how this 1 leads to that 3? If you're counting on, let's say, we asked the question, how many 3s can we get from this 1 root over here? So this is going to give us like 1 is going to give us the answer of like 3s question mark. How many 3s are we going to get from this 1? We're going to get 1 3 here. Okay? And this 2 value right here, this pink one, we're going to ask how many 3s can we get from this number 2 tree, because this is its own tree right here. And okay guys, I see my mistake. So how many 1s can this 3, or how many 3s are in this 1 value? There's actually 2. If you guys see it right here, which is this value and this value. Okay? And that is going to give us 2. But how many 2s are in, how many 3s does a 2 have? Right? Because if we look on this side, we're going to be like, oh, okay. So this side has 2 3s. 2 3s. On the one side, it has 2 3s. And the other side, which is 2, it has 1 3s or whatever. So this right here is actually going to be 1. All right, so we're asking how much does this side of the tree have 3s and the right side. So how many plus 1, like if we just look at it like that, how many plus 1, plus 2, and then we like start from here, right? So how many 3s are in this side, how many 3s are in the other side on the second step. So that's going to give us 1. So our answer here is going to be 3 is actually going to equal to 1 plus 2. Hopefully that makes sense to you guys. We're just grabbing these values, like just consider this like an array or something. So how would we like code this in Python if we want the left side and the right side to give us our answer? So what we actually need to do to get the left and right side of the problem is we need to start from what the 1 value is, okay? And our 1 value is going to give us 1. And our 2 value is going to give us 2, because there's 2 steps. So if our 1 and 2 is going to give us 1 and 2, if we put this into like an array, we're going to get 3. Well, you would have to have an array size of n. So if our n was 3, then we would have an array size of 3. And then we just basically get 2 and 1. So that would be like 2 plus 1 is going to give us 3. We should have a if statement that checks if the number n is 1 or 2. If n equals 1 or n equals 2, then we would just return n. The tricky part is when we get to 3, because that's going to be value 1 and value 2. So we would need to have like a for loop that starts at, let's say we start at 3, and then we go all the way to like n plus 1. It just depends on your programming language reads for loops. Okay, but you would have this in a for loop, and then you would also have an array list or a list of numbers that we can put our numbers in. And then we would say list at I would be equal to list at I minus 2 and plus list of I minus. Sorry, my headphone died. But yeah, that's how we would kind of generate this list. And then, so if we want to get the answer, we would just return list at n minus 1 plus 1. I would think minus 1 if we are starting at a 0 list index. So let's code that. What is this going to actually be for time complexity? Okay. Time, it's just going to be O of n. Yeah, O of n, because we're just looping through the list. We're looping through how much n value is in here. So if n gets bigger, so if n equals like 7, then our time is going to get bigger. And this is like a dynamic programming approach. So we're going to start coding and then Python. We'll go Python and then Lua. So if we have a list of numbers, so we're going to do if n equals 1 or n equals 2, then we would return n. Otherwise, we're going to say, we're going to make a list of numbers. Let's just say values, I guess, since we can't use a list. It's reserve the word in Python. Okay, so for each number, we don't really need this in a range of 3 all the way to n plus 1, because if we go in Python, if our list size is 5 or whatever, or if our n is 5, if you use range, then we would start at 3. Okay, 4, 5. We would start at 3 and then loop all the way to 5. Actually, would loop all the way to 4 because it doesn't include 5 in here. So now we can just say values at, I guess, I. We kind of need this now for the indexing of numbers because we have 1 and 2 in this list already. So it's going to be, oh wow, we actually need a list of numbers here that does 1 and 2 because that's going to be our 1 and 2. And now we just do values at I minus 2 plus values at I minus 1. But I wonder if it's going to skip 1 and 2 though. We would probably need this. Honestly, we probably need this in here then. No, it shouldn't be. It should go from 3. I honestly don't know what I is gonna be, guys. Give me a second. Sorry. Set does not is this a set? Just use an array. Oh, I'm gonna have to append. Okay, this looks fine. Okay, sorry guys. I had to just change this 3 that I had to 2 because 0, 1, 2. And we actually want to go to the third value. And then this is going to be 2 minus 2, which is going to be 0. And then if I is at 2, 2 minus 1, which is going to be 1, which is 2. Okay. And then we just print values at n. Minus 1 maybe. Okay, hopefully this works. Okay guys. Yeah, this should be it in Python. Honestly, we probably don't even need this anymore. Because if we're storing 1 and 2 here, then values at 2 minus 1 is going to be already stored in here. Yeah. So if we submit it, it should work. Okay, that's great. So now we're going to code this problem in Lua. So now we just do function, let's call it climb stairs with n. Actually, we should just make the list here. We go values equal 1 and 2. That's our table. So then we just say for I starting at 2, maybe 3, and then go all the way up to n plus 1. N plus 1 because we want to go to the last number, hopefully. I don't know if it's inclusive or exclusive, but we gotta just say values at I is going to equal to values at I minus 2 plus values at I minus 1. And then we would just return values at n minus 1, or is it just going to be n? I think it's going to be n. Print climb stairs at, let's do 3. Climb stairs 3 at 3. Okay, now we can just, we're going to see if it works for everything. So 5, 3, 1, let's do 2 as well. And then we can do 8. Yeah, so it looks like it's working, guys. Wait, 1, 2, 3, 8. Oh yeah, 5 is supposed to be 8. Sorry, I was actually just looking at Fibonacci numbers. If you guys know what that is. So I was kind of weirded out by them numbers. Okay, but it should be fine, guys. So you might be thinking, okay, so what's the better solution? I don't even think there could be a better solution. Well, guys, there is actually a better solution to that, which is just space efficient. So this solution is O of n time, and then space is going to be O of n as well. So then we actually don't need here, watch this. If we start our array again, and 1, 2, 3, 5, 8. Okay. So what we're doing is basically, if we want 3, we look at the last two numbers, right? So we look at 2 and 1. But if we want 4, like if we want also 4 here, 4, we actually just need the values of 2 and 3. So basically what I'm trying to get to is that we just need to store 2 values if we want to get to this solution. So how would we do that? Well, basically we have like a first number. I'm going to call it, this is going to be Fn for first number. And then this is going to be Sn for second number. And then we just name this our An for answer, Ans for answer. So basically we just need our Fn plus Sn equal Ans. And once we move like to the right, let's say we shift right, okay? That means we can just replace this Sn with Fn. That means we just need to replace Sn with Fn and our answer with Sn. And then we can put our Ans over here, okay? We just need to basically keep moving through this list, and then we don't even need this thing anymore. We don't need this 1 because we just need these 3 numbers if we're trying to get to like 4th. And then when we go again, we just keep swapping the Fn value with Sn and also Sn with answer. So how do we even do that? Hopefully it makes sense to you guys, but I'm going to draw it one more time so it actually it looks good, you know. So if our Fn, let's say we want to find a number. Let's say we want to find, what do we call it? Our n. If our n equals 5, let's go through it. That means Fn is going to start at 1. Sn is now going to start at 2 since we just used 1 and 2 for our starting point, and Ans is going to be equal to 1 plus 2, which is 3. Okay? So this is our first iteration, right? And then our second iteration is going to be, okay, replace this Sn, put it here. Gonna do this over here, 2, 3, and then whatever 2 and 3 comes up, we do 5. And then here now, we do 3 goes here. Sn replaces Fn, so 3. And then here we go 5, because remember this is going like this. Hopefully you guys see it. Bink, 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 bink. And then 3 and 5 make 8. So we just replace Fn with Sn and Sn with Ans. Hopefully that makes sense to you guys now that I've drawn it. And then you just keep repeating that pattern until you get to n, which is, let's just keep going, honestly. 4, 5, 5, 8, what is this going to be, 13, and then 8, 13, 21, 1, 2, 3, 5, 8, 5 is 8, 5 is 8, oh, wait, oh my god, I'm such a troll. Sorry guys, Sorry guys, I wrote this wrong. So Fn and Sn, right? If we're at the first value, that's going to mean we grab this, which is 1, Sn, which is 1, Sn, which is 0, actually. Wait, okay. First value. How do we get 1? Well, we probably need to do this, 1 and 0. And then that's going to give us 1. And then this is going to turn into here. This is going to turn into here. And then we get 2 here. 5. And then now you do 3 here, 5 here. And now that 5 is going to be equal to 8. So hopefully that makes sense. So let's say 6, 6, 6, 6 is 13. Yes, this is correct, working perfectly fine. Actually, it went all the way up to 7, even though we asked for 6, so we probably don't need this plus 1 here, sorry. Okay, now we'll code that problem just using the Fn and Sn. So we just need a first number, which is 1, second number, equals 2. And then now we just need to answer, which is, we'll start at 0. For each number in range n plus 1, we're just going to do answer equals first number plus second number. Then we will replace the first number with our second number. And then we will replace our second number with our answer right here. And then at the end we just return our answer. So hopefully this works. Oh man, okay. So it's not n plus 1, it's probably just like that. And we probably need to check if n equals 1 and n equals 2. If n equals 1 or n equals 2, then we would return n. Did I mess something up? I think I need to go for in range that start from 2 all the way to n, because we don't need the first two numbers. And plus 1. Okay, so it's gonna be weird. Sorry, we need this 3 because, you know, we're starting from here in this for loop. And then we're going to n plus 1, which is, if our n was 5, then we actually want to read all the way until this 5. So we have to make it a 6. Alright, so this should work now. Use first number, second number. Hopefully that makes sense. Let's move on to Lua now. Alright, so in Lua, you just do function climb stairs with just Fn, Sn, which is first number, second number. First number, second number equal to, I don't know if you can do this in Lua, but hopefully. It's just saying put 1 into first number, 2 into second number. And then now for I equals 3, all the way up to n, we're going to do the same thing up here, honestly, but we're just going to do, oh, we also need to answer, huh? Answer. So answer equals first number plus second number. And then now replace our first number with second number, and then replace our second number with our answer. And then return the answer here. I'm just gonna make it local. Okay, it should be fine, hopefully. 13, okay, that's good. So I should be seeing the Fibonacci sequence, if this is correct here. Dang, okay. Yeah, I need to do if n equals 1 or n equals 2, then return n. There we go. Okay, now I should be saying the numbers 1, 2, 3, 5, 8, 13. And this is our answer. And as you can see that our time is still the same because we're looping through n times in this for loop right here. That is why our time complexity is O of n and our space is going to be big O of 1 since we don't use any space. We just store our values in these variables and it's always going to be constant. So we're just going to use 3 spaces and it doesn't even matter what this n is because we're only going to keep 3 numbers, store 3 numbers. This one you store n numbers because we increase this values table depending on the numbers. So yeah, hopefully that makes sense to you guys and hopefully you guys enjoyed. I mean, that's kind of a tricky problem to wrap your head around. Alright, you guys know what to do. Like, subscribe, and comment any questions that you guys have. So yeah, see ya.